Starting a home lab in 2026 is easier than ever, but it's also really easy to buy the wrong stuff and make it way more complicated than it needs to be. In this video, I'll show you how to build a modern home lab from the ground up with a focus on the two things that matter most: the hardware you should start with and the software you should run on it. In the next video, we'll take a look at the software plus applications that you can then run on top of the hardware we'll be discussing in this video. We are going to head over to Micro Center to get started with the hardware portion. Micro Center sells just about everything you need to start a home lab. I'll walk through what I'd actually buy today and why without overspending or overbuilding. Then we'll head back home, look at the best OS options, and talk through how to choose the right one based on what you actually want to do. By the end, you should have a clear idea of what to buy, what to install, and how to start the right way. Quick heads up before we get started. If you sign up using the links in the description for the North Jersey remodel or the Austin grand opening, you can get a free 128 gigabyte flash drive. Okay, so we are going to get started in the NAS department. And for the most part, a NAS is where I think everybody should get started. This is where you're going to store all of your documents, your media, your photos, etc. Now, you really have two paths that you can go down. You can buy a pre-built NAS or you can build a DIY NAS. And that's going to depend on really the operating system route that you want to take. But with that said, there are third-party operating systems that can be installed on a first-party NAS device. So the reason I think this is where everybody should get started is because you can install applications on here. So what that means is there are first-party applications and then things like Docker containers that can run directly on a NAS. So there are people out there where a NAS device is the only thing that they actually need. So you have one device that runs everything. It stores all of your files, and also it can run all of your applications. So a few important things to think through when you're purchasing a NAS device. The first is going to be, what type of data requirements do you have? So when I say that, that's going to depend on the total number of drive bays that you're going to want to buy. So with NAS devices, you will generally use something called RAID. And what that allows you to do is utilize a redundant array. So from that perspective, if one of these drives dies, you won't actually lose any of your data. Now, there are different types of RAID, and we'll talk about that later. But for the most part, this is where I think everybody should get started. So if you're not interested in starting with a NAS device, you can also get started with something called a hypervisor. So we're going to move over to that section now. Okay, so while you can go through and install applications on a NAS device, there are a lot of people that want a dedicated hypervisor. Now, there are various different types of hypervisors you can use. You can buy a mini PC if you wanted to. You can build your own hypervisor using just about desktop parts or even server parts if you wanted to go down that path. You can even use an old PC, but if you did, you'd have to probably upgrade some components. So the reason why you would want a hypervisor is generally because you want to run virtual machines and containers. So what this allows you to do is virtualize full desktop environments. That's kind of the easiest way to think about it. So having one dedicated device from a hardware perspective, but running various different virtual servers on top of it. So a hypervisor allows you to do a lot of different things and gives you a lot of flexibility. Just about all of the applications that can run on a NAS can also run on a dedicated hypervisor. So a lot of people like to use NAS devices for storage exclusively and a hypervisor for applications specifically. So that's the main decision that you're going to have to make. Now, if you want to go through and set up your own hypervisor and build it yourself, the biggest thing that you're going to have to think through is exactly how many virtual servers you're going to want to run on it. So the big thing to remember from a hardware perspective, the first thing that you're generally going to run out of from a resource perspective is RAM and storage. You can use AMD or you can use Intel, and there are pros and cons to each of those. Intel generally has better power efficiency depending on exactly what you're doing, more from an idle perspective. But Ryzen tends to be a little bit more cost effective. But from a performance perspective, you're really looking at cores and threads. Just keep in mind, again, you could have the best CPU in the world, but if you don't have the RAM and the storage to support various virtual machines and containers, the processor isn't really going to matter. So that's the first thing and the main thing that you should keep in mind. Okay, so we are in the networking aisle here, and this is where things start to turn. So for a lot of home users, you're going to have an ISP router. And what that means is that your internet service provider, it could be either a combination modem and router, or it can just be a dedicated modem and a dedicated router. But generally, they're going to be very limited, and you're not really going to have much that you could do on them. And that's where looking into a dedicated cloud gateway, something like a Ubiquity Cloud Gateway, is one of the paths that you can go down if you're interested in upgrading your networking. What this is going to allow you to do is create something called VLANs and utilize firewalls. So a VLAN is a virtual local area network. And what that means is that you're basically segregating your home network. So you can go in and create a network for your trusted devices. You can create a guest network for your guests. You can also go in and create one for your IoT devices, cameras. There's basically endless possibilities. But without one of these, you're really not going to be able to do that. So why you would want a segregated network is because you can then segregate that traffic and create firewall rules that ensure that each one of those VLANs cannot access one another. So this increases security by ensuring that more of those untrusted devices cannot access your trusted devices. Now, you have a few different paths that you can go down. If you want something like a Ubiquity Cloud Gateway, it's an all-in-one device for a lot of people. You might want to add a switch to it, but that's going to allow you to create all your VLANs and go through and set up port profiles and various things. That's where I think a beginner should get started. But there are other devices that you can purchase. You can even build your own router if you wanted to. And you can use an open source operating system like OPNsense or pfSense, which we'll talk about later. But this is one thing that you have to think through if you go down this path. And it's what networking speeds from a throughput perspective are you going to want? So do you want to utilize 2.5 gigabit? For most people, especially home users, that's perfect. That's where you should get started. But if you want something more upgraded, you're going to have to look at something like a 10 gigabit switch, which then will allow you to have 10 gigabits of throughput from device to device. Now, networking is a full topic in itself, and I can't give a full overview in this section right here. But what I want to say is that this is one of the best upgrades that you can make, because with your NAS device, your hypervisor, when you add networking on top of it, you're able to segregate all of that traffic. And then at that point, you're building a very powerful home network plus a very powerful home lab, and you're really not doing that much. It's 3 or 4 devices, and you're going to have just about everything that you need to have everything functional. Okay, so we have our NAS device, we have our hypervisor, we talked about networking. Now let's talk about power for a second. And UPS devices are something that I think every single person needs. And it's one of those situations where if you don't have one right away, there's going to come a point where you're probably going to regret not having it. The reason why is because from a power perspective, you want to ensure consistent delivery, especially for things like NAS devices with RAID. So if you're in the middle of a write operation and you lose power, UPS is going to ensure that that NAS device stays online, but not only that it stays online, it powers down safely. Now you can configure a UPS device to work with all of your devices. You can configure it to work with the hypervisor so it automatically powers down. So this is a very versatile thing that I think every single person should have in a home lab, mainly because there are going to be times where you lose power. And you want to ensure that you don't have any data loss, and you also don't have any corruption from that power outage. So this is one of the things that I think every single person should have as part of their home lab. The only thing you have to think through is sizing. If you have one NAS device, you really don't need something like a 1500 VA UPS device. But if you're going to put your router on it, your NAS device, your hypervisor, if you're going to put everything on this, get something like a 1500 VA so that when a power outage occurs, you have enough power to go through and last throughout either the entire power outage or long enough to safely power everything down. So the last place we're going to stop is the Raspberry Pi section. And you can do so much with a Raspberry Pi. It's kind of crazy. They are so versatile. So you can do things like set up Pi-hole, which allows you to block ads on your entire network. It's a black hole for ads. So basically what it does is it goes through and every DNS request, it checks to ensure if it's safe or if it's something like an ad or malicious, and that gets blocked and the safe traffic gets let through. So from a networking perspective, if you wanted to set up Pi-hole as your DNS server, using a Raspberry Pi is great because you could buy one or two of them, set up redundant Pi-hole instances, and then at that point, your entire network traffic will go through those DNS servers. But you could do so much more with a Raspberry Pi. If you wanted to, you could even set up a VPN server. So there's Pi VPN, which allows you to set up and run basically a script which will automatically install everything. You do some basic port forwarding and you now have a VPN server. You can run lightweight Docker containers on this if you really wanted to. The point is that they're very versatile. And not only can they do one thing, they can potentially do multiple things. So this is one of the things that I think a lot of people should potentially add to their home lab. And it's not necessarily something you have to get right away, but there's going to come a point in time where you're going to see value in adding one of these to your home lab. We are back home, and it was actually a lot of fun to walk through Micro Center. They have so much stuff, and you can basically build out an entire home lab just from that store. But we talked about a lot of the hardware there. So let's talk about the operating systems that you can run on the hardware that we discussed. So we're going to go based in order of the hardware we looked at from the store. And the first thing we discussed was NAS devices. So like I said, you can run a first-party NAS operating system or a third-party NAS operating system. If you want to run a first-party NAS operating system, it's pretty easy because you don't really have to worry about much. You're going to plug in the device that you purchased, you're going to run through the setup process that comes on that operating system, and then you're going to configure it. But let's say you wanted to run a third-party NAS operating system like TrueNAS or Unraid. That's going to depend on the hardware that you purchased and if it is capable. So utilizing something like a Synology NAS in that case is not really the path you're going to be able to go down with third-party NAS operating systems. But let's say you bought a Ugrain NAS. Let's say you bought something like a DXP 4800 Plus. You can install TrueNAS or Unraid directly on that device. So you don't have to build your own NAS to do that. You can run one of those operating systems. So which one should you use? Well, that's where things start to get a little different. So with TrueNAS in specific, you're going to be utilizing ZFS. ZFS is the file system that it runs. With Unraid, you're going to be able to utilize ZFS as well, but we'll say a more scaled down version of ZFS compared to TrueNAS, or you can set up an Unraid array, which will allow you to utilize mixed size drives and have parity to ensure that if one of those drives dies, you will not lose any of your data. The only thing with an Unraid array is you have to ensure that the parity drive is at least the size of the largest drive in the array. That's kind of how it works. So those are your two options. Now, from an application perspective, you're going to be able to run through and install just about any of the applications that you need or want. They just do things a little differently. TrueNAS sets them up as Docker containers, as well as Unraid, which has their own app store, and it's actually very easy to set up apps. TrueNAS just added container support. It's very, very new. I think it's actually still experimental, but you can actually run containers, Linux containers in specific, directly on the operating system. So those are the two options you're really going to have if you wanted to go a third-party NAS operating system route. Now, let's say from an application perspective that you really just wanted to utilize a NAS device as a NAS device. So for example, let's say you bought something like a UniFi UNAS Pro 4 or something like that, because that's really designed just for storage. You would need something to run your applications, and that's where something like a hypervisor comes in. So in store, we talked about all of the different hardware options you can use. You can use mini PCs, you can build your own. You can even take an old PC and turn it into a Proxmox server, and that's a very popular option for a lot of people. But I said Proxmox, and while I think that that's the place most people should get started, and it's mainly because there's so much support online and so many tutorials and guides that you can follow to do exactly what you want to do, there are other options as well. So I've used XCP-ng in the past. I wouldn't say it has the support that something like Proxmox has, but overall, they're both enterprise-grade hypervisors. So you're going to be able to do just about the same thing on both of them. It's just that if you're a beginner and you need support, Going the Proxmox route is probably going to be a little easier for you, but overall, they're great options. I have a lot of friends that run XCP-ng and they love it. So it's not to say that you can't do either of them. You can. Now that's if you wanted to go down the hypervisor route. Let's say you just wanted to set up a server. You can run a Linux operating system like Ubuntu server on it, set up Docker, run a bunch of applications, and we're going to talk about a lot of different self-hosted applications in the next video, but you can run those applications and they will all run on Ubuntu server. You don't even have to get into virtualization. So that's the one thing you have to decide. Do you want to use the hardware that you have with just a dedicated bare metal operating system like Ubuntu server, or do you want to go the virtualization route and use something like Proxmox or XCP-ng? The one thing I'll say is if you have a lot of RAM, you're better off, in my opinion, going the hypervisor route because you could dedicate specific resources to each of the virtual machines and containers that you intend on running on those hypervisors. But if you have, let's say, a smaller device, a mini PC that might have 8 gigs or 16 gigs of RAM, you can actually run everything bare metal by installing Ubuntu server or Debian and just run the applications directly on there. And the thing is, it doesn't even have to be just the command line version. So there are a lot of people that get started by running one of those operating systems with a GUI. So if you're used to something like Windows, you don't have to use Ubuntu server. You can use Ubuntu desktop. You're going to be able to do the same things. You're going to have a regular GUI that you're used to interfacing with. And while the setup in general is going to be the same, you can actually use something that will be more comfortable to you. So those are a lot of different options, but with that hardware, I want it to be clear that you can run just about any of these operating systems and you'll have a very powerful setup. So with your NAS and your hypervisor and or application server setup, we are going to talk about networking. So I got into it in the store, but from a networking perspective, you can go through and create different VLANs if you were to get networking hardware that supported them, and then segregate your network with firewall rules. That's important because what that allows you to do is take untrusted devices and separate them from trusted devices. Now, if you went with something like a Ubiquiti Cloud Gateway, that is going to come with the operating system that you want to use. But let's say you wanted to go through and use something like pfSense or OPNsense. You can actually buy specific hardware or build your own hardware and run those operating systems directly on that hardware. The key is you need to have a NIC that has 2 ports. So you're going to have one for WAN and one for LAN. So the way you kind of have to think about it is the WAN port will be used from your modem, and that will be for the internet traffic, and the LAN port will go to a switch, and that's how you'll pass through all of your VLANs and everything that you need on that side. So which path should you go down? The truth is there's not a right or wrong answer, but if you're a beginner, I'd suggest going with a UniFi Cloud Gateway. It's going to be very powerful for you, and you're going to be able to do everything that you need, but it's going to be a lot simpler to set up and manage in the long run. If you're a power user, or let's say you just wanted to learn more about networking, I would definitely consider pfSense or OPNsense. It has a much steeper learning curve, but they are super, super powerful, and they're true enterprise firewalls. So you're going to be able to not only learn a lot, but you're going to be able to set up a very complex networking setup at home and ensure that you can do on a granular level just about everything that you want to. So it's not a clear answer for everybody. I would look at your individual needs and ensure that if you want to learn more, you look into something like pfSense or OPNsense. And that's not to say you can't learn on Ubiquiti hardware. You can. It's just that since it's more beginner friendly, you can't get into the granular details you can with pfSense or OPNsense. Now, there are other routers that you can purchase. You just have to ensure that if you go down that path, you can configure VLANs. That's the one thing that is going to allow you with firewall rules to segregate your network. And that's the big benefit of going down this path. So these aren't your only options. I would just suggest ensuring that whatever hardware you pick out if you utilize the operating system that comes on it, that you can properly segregate your network. So the last thing that we talked about was Raspberry Pi devices in the store. And I walked through and showed that you could set up a VPN server, you could set up Pi-hole, you can run Docker containers on it. To do all of that, you're going to utilize generally Raspberry Pi OS, which is a Debian-based operating system optimized for Raspberry Pi devices. So there are other operating systems that you can install on a Raspberry Pi, but Raspberry Pi OS is optimized for them. It's going to have the best overall support based on what you're looking to do. So this is super, super helpful to your home lab because of how versatile they are. So you can do a lot of different things on a Raspberry Pi, and they're generally cost effective. At one point in time, mini PCs had kind of taken over from a cost effective perspective, or I should say performance to cost perspective. But as time has gone on, mini PCs have gotten to be more expensive, which has made Raspberry Pi devices indirectly more affordable. So if you go down this path, I would suggest installing Raspberry Pi OS. There's a ton of great support and applications that you can find guides on to do exactly what you're looking for. So that's a general overview of the hardware that you can purchase and the operating system choices that you have to run on that hardware. In the next video, we're going to talk about the software or the applications that you can run on this hardware. And that's where this starts to turn into a full home lab, because now we have the hardware or pieces of the hardware. And keep in mind, home labs are built over time. I'm not necessarily suggesting you go and get all of this at the same time. If you can, that's great. But home labs are built over time. So if you start small and you set up specific services on the hardware that you have, that's where a home lab starts to grow and becomes something that you're going to rely on every single day. So I hope you got some value out of this. Thanks again to Micro Center for allowing me to go down and film in store. That was a lot of fun, and it was a great overall experience. So again, hope you got some value out of this. If you have any questions, feel free to leave those in the comments. But other than that, if you made it this far, thank you very much for watching. I'll see you guys next time.